Good morning, everyone. It's great to see you all here. Thank you for joining my talk. I'm Nupur Agarwal. I'm honored to be part of this wonderful conference today. And I will today share my learnings about Kafka. To be specific, I will share my lessons that I have learned while working with Kafka Producer, especially for high throughput applications. I hope this session provides you with some valuable insights and key takeaways. By the way, how many of you have actually worked with Kafka? Wow, lot of hands up. So I think this talk is going to be interesting, and I hope that this content will be relevant for you guys. Agenda. So we'll start with the introduction. Then we'll see that why we have implemented Kafka, how did we implement Kafka, what were the problems emerged when we implemented Kafka, how did we address misconfigurations that we had, how did we achieve high performance, and then key takeaways from the session. Before going into the content, let me introduce myself. My name is Nupur Agarwal. I'm currently working as a tech lead in ING in Amsterdam, where I'm based for more than 6 years. I'm originally from India. I have been mostly working in IT for more than a decade in backend programming. I have worked in different sectors like banking, telecom, supply chain. In ING right now, I'm working on data consistency and completeness ensuring, mostly in lending domain where we have huge lot of data that we transfer via Kafka. So this is mostly about me. Besides work, I love hiking, I do running, gym sessions, and I also like to spend time with my 3-year-old beautiful daughter who keeps teaching me things in her own way. I'm always open to connecting and discussing new ideas and thoughts. So feel free to scan my LinkedIn QR code if you want to message me. And I'm here in the conference for 2 days. So find me open for discussion and connect. So let's dive in with the content. So here, I will say in today's data-driven world, data is so important. And now we have so much huge data load coming in from different sources. So it becomes more ensured to ensure that we have operational excellence. In our use case, business wanted near to real-time data ingestion for events of volume that can reach up to 500,000 events daily from one system to another system. And our database is source of truth. What does it mean is, like, whatever changes in our database should be sent to consumers, to the downstream systems. And also, data should be consistent. Consistency is a key here. So that was our business use case. And for this, we decided to use Kafka. So before going into more about the problems, we'll first see how Kafka works and some internals of Kafka and why and how did we choose Kafka. How Kafka works. So Kafka is a distributed event streaming platform. Just a moment. Yeah. Sorry for the interruption. So Kafka is a distributed event streaming platform. Here we have producer, Kafka cluster, and consumer. What happens is producer sends the data to Kafka cluster, consumer polls Kafka cluster, and reads the data from the Kafka cluster. Here in the Kafka cluster, message is replicated in different partitions to ensure that message is durable and it's not lost. So that's the basic working of Kafka. And I hope now everyone have the basic picture of Kafka so we can move forward. Why Kafka for data ingestion? Why did we use Kafka? First, it's an event streaming platform and it allows publication of tons of data and subscription of events, which is very ideal for real-time data ingestion. Second, it's high volume and near to real-time processing. Kafka enables to process and analyze data at near to real-time. I won't say real-time, but near to real-time, which makes it very suitable for our business needs. Scalability and fault tolerance. It's very, very important. So I think that's the feature of the Kafka that makes it stands out in the event streaming market. So by adding Kafka brokers, Kafka can be scaled out and it ensures that it have the capacity to handle lots of data whenever needed. This ensures that as data load grows, our system also grows automatically. Second, it's fault tolerance. By replicating partitions across multiple brokers, Kafka ensures that data is not lost, even if any broker fails. Next is fan out to multiple consumers. You can easily distribute data to multiple consumers at the same time by putting your data in the topic. So that's why we choose Kafka for our business use case, and we see these 4 major advantages for choosing Kafka. Implementing Kafka. Now, yes, we know that Kafka suits our business needs. Now we want to implement it. Let's see how we implemented it in our project for initial setup. Now this is how our Kafka journey begins. We create a topic. Topic has partitions. Topics are basically kind of feed names to which messages are sent by the producer. There are partitions where messages are replicated for keeping it durable, and it allows also Kafka to scale horizontally. Next, we configured our producer. Producers are kind of the applications that send messages to the topics. Then we created message. We send the message to the Kafka topic. So once the producers are configured, they can just create and start sending messages to the Kafka topic. Its initial setup is very easy. So yes, we also implemented Kafka in our use case. Team is happy. We have basic data pipeline setup. We can produce message. Consumers can poll messages. By default, we are now using the default settings of producer. We have not changed anything. Pipeline works, and yeah. So initial setup is, I think, quite easy and quite fast with Kafka. However, as we continued using Kafka and our data load keeps increasing, we began to notice some subtle issues. What were those issues? Like laggy throughput. Throughput is the rate at which messages are sent to the Kafka topic. Those started to slow down, especially when data load was big, causing delays in our data ingestion and data processing. So it was no more real-time data ingestion. High resource usage, high memory and CPU usage, retries and timeouts. So Kafka was retrying again and again. Requests were getting timeout. So this was actually getting frustrating, and it was difficult to pinpoint the exact cause of the problem, that where does the problem lie? Because sometimes it gets difficult to find out the root cause. We were unaware why these issues were occurring, especially since everything had worked initially like a charm. It became clear that default settings were not sufficient for our use case, and as the data is growing, it no more suffice our all requirements. Before moving towards how did we tackle these challenges and optimize our Kafka setup, let's first quickly see what actually throughput means in event streaming world. This will help us understanding the solution. Throughput. Throughput is how many number of messages Kafka is going to process in some specific period of time. If we say we have a higher throughput, means more data is being processed efficiently. Throughput is a key metric, to know how well your system behaves when the data load is high. It can be measured using various tools and metrics. And it's very important to set up monitoring tools like Prometheus and Grafana since starting to monitor your throughput. Now we know that how important is it to monitor your throughput. Let's see some internals of Kafka producer. Let's first understand how the messages are created, sent, and processed, which is very critical for optimizing the performance. How Kafka producer sends data. First, we create a producer record where we set, this is our topic name, this is our record, and we define the key, partition key. If we want our data to go in single partition, then we define partition key, otherwise we can just keep it as a null. Then we have a Kafka template send method. So which returns as a completable future. What does it mean is this method queues the data in the memory and it returns immediately. So if there is any error, it will throw in the future, not at that moment of time. So that is the meaning of having this completable future here as an output. Therefore, if data needs to be consistent and complete in both the systems, if you are using Kafka for data streaming, then you need to ensure that you are capturing those errors which are received in the future if you really want your data, if you really want to know if you receive any error while sending. And for us, data consistency was very important. So how to know the status in future? So for this, in completable future, you have a lot of methods like when complete async, and there are other methods through which you can have a callback function, and that callback function will take your result and exception. So if there is anything in the exception, you can log it, and if you receive a result, you know that your message has been sent successfully on the Kafka topic. Here, if you see, I have just commented it that we are also updating a status in database to ensure the data consistency, that we know that data was sent successfully in the Kafka producer. So that's how you can ensure that you know if data consistency is important for you. It's good to know the status in the future. If not, then you can also skip that part in your application and in your producer configuration code. Understanding Kafka producer. Now that we have a clear understanding how Kafka producers work, send messages asynchronously, let's move on to see the message lifecycle. What does I mean by that? How the message is created, how the message is batched, and how did it reach till the Kafka broker. So we'll see the complete message lifecycle starting from producer till Kafka broker. And that is very important for optimizing performance. So if you're working with producer, it's very important to understand the complete chain of flow. First, message is created, then messages are batched. I will explain the batching process in the next slide in more detail. Messages are batched, then messages are sent to the broker when the batch is created. When the message is received by the broker, either you receive the acknowledgement from the broker or Kafka automatically retries. So that's the basic flow of a message lifecycle. Let's see the batching process in detail. So here you see we have n number of messages which are batched into a single batch. So here we have two main properties, batch.size and linger.ms. So linger.ms property tells us that producer needs to wait for this specific period of time before sending the batch. And batch size tells you the maximum number of messages that you can put in the batch, the maximum size of the batch. So what does it mean is these messages are collected, these n messages are collected into a single batch, and then a single request is sent to the Kafka cluster. So you won't send n number of requests to Kafka broker. You will batch the request in a single batch, and then you will send a one request with one batch to Kafka broker. So that's how this batching process works. So now we know how the batching works. Let's see what are the default configurations that are being used in the batching process. So once you have a message created, your message enters into the batching window. In the batching window, you have some configuration properties like linger.ms and batch.size, and the default value for linger.ms is 0ms. What does it mean? The producer sends message immediately to the Kafka broker without any wait. So which is actually good for low latency, but it can be possible that it's not good for your use case, as it reduces the efficiency of your batching process. Then we have batch.size, which is by default defined as 16 KB. Means that till 16 KB, your batch messages will be batched and it will be in the memory before sending it to the Kafka. Now, default setting may not fully utilize the efficiency in your application, and the larger batches can reduce the overhead of network communication and improve throughput. So it really depends on your use case, that what is really important for your use case. It could be the case that these default values are enough for your application, but it can be that if you want to really use the batching process very efficiently, then these properties might not be enough for your application. Next, when the messages are batched, messages are sent to the broker. Now, when message is received by the broker, we have a property named as ACKs, acknowledgement. By default, ACKs is set as all in Kafka. So if ACKs is all, that means when you send data to the broker, data will be replicated into the partitions. And when data is replicated in all the partitions, then you receive the acknowledgement back from the Kafka broker that yes, your message is copied and replicated in the cluster. Now your data is in the Kafka topic safely. Your data is safe with us. So that so by default ACKs is set as all. But let's suppose you don't receive acknowledgement from a Kafka broker. You cannot wait indefinitely, right? So for that, we have a parameter request.timeout.ms by default, which is set as 30 seconds. What does it mean? That your producer will wait for 30 seconds for the acknowledgement from the Kafka broker. If within 30 seconds, your producer doesn't receive any acknowledgement back from the Kafka broker, then producer needs to retry. So these are mostly default configurations that are used in the stage when the messages are sent to the broker. Then our next step comes, which is about the retrying, about the scenario where you did not receive acknowledgement from the broker and producer wants to retry. So here, if message fails to be acknowledged, producer will try retrying it, and there is a property for that, retries, which is by default set as max int. So your producer will retry max int times to resend your message to the Kafka broker. But then your application cannot retry multiple times, like infinite times to retry sending your message. So there is a catch. For that, we have a property named as delivery timeout ms. So delivery timeout ms is set as 2 minutes, and it will limit the total time that a record will take prior to sending, like time to await acknowledgement from the broker and the time allowed for the retryable sending failures. So for that complete time, this is the delivery timeout ms, which is defined as 2 minutes for a particular message. So in this 2 minutes, Kafka will also receive the producer will wait for the acknowledgement, and producer will retry. So that complete time for a message is 2 minutes by default in the Kafka, which is, I think, fair enough. 2 minutes is a good amount of time for retrying and getting acknowledgement in case of failure, in case of worst case failures. Now, by fine-tuning these configurations, the configurations that we discussed till now, so these were the default values defined by Kafka. But by fine-tuning, if your application is working good with these default configurations, you don't need to tune any of this. But in case you need fine-tuning of these configurations, you really need to play around with these parameters for your particular business use case. You can achieve a balance between throughput, latency, and reliability. So you need to see what is more important for your application. Is it latency, reliability, throughput, or combination of some performance matrix? For us, because throughput was important, so it helped us to make informed decisions to enhance our Kafka setup. Now we started digging into Kafka internals. And while digging into Kafka internals, we found out some transient errors and non-transient errors. And like as I say, like it's very important to understand and delve into internals of any software to actually find out errors. And that's what we did. And after studying on these parameters and internals of Kafka message lifecycle, we understood about some kind of errors. Transient errors. What are those? So these are the temporary failures that resolve themselves without external intervention. So you don't need to intervene. After some time, they will automatically resolve. Like network congestion. So when you have a high load of data, your network could be congested. So you will find some transient error in your application. But for example, in Kafka, you don't need to do anything about it. Kafka internal has own retry mechanism to solve it. So Kafka will internally handle it. So when you encounter any error, you need to find out whether your intervention is actually required or not. So for these kind of transient errors, Kafka will automatically resolve it. And in case if retries also fail, then of course application level logic handling is also required if needed. But I think retries are enough for handling these transient errors. Next comes non-transient errors. So these are main issues where we should focus on. They are persistent issues which actually require external intervention to fix them. And like common causes of this in Kafka could be incorrect topic name, incorrect schema of your data, authentication or authorization failures, or some misconfigurations. So these are main causes of non-transient error. But for all these errors, your analysis and your fix is required. So addressing these issues promptly is needed from the developer side if you want to maintain integrity of your data pipeline. Detecting these kind of errors, what can we do in the application side? We can have callback function like we saw in the last slide. We can have callback function, we can have alerting, we can have monitoring in place on production, so that we can identify these kind of error at an early stage. Non-transient errors that we identified at our end. So I see first one is small batch size. As I mentioned, the default batch size is 16 KB, which we identified as kind of low for our high throughput application, for our high load of data. And it also increases the overhead of CPU. But you really need to play around with this batch size. You cannot only tweak your batch size property. You need to tweak batch size with the linger.ms property. Because linger.ms is the time period for which Kafka waits to fill up your batch. So for us, the linger.ms was also configured as 0, which is by default, which means that every message, as soon as it was received, it was sent immediately without any wait, without waiting for batching. So it was killing the batching efficiency, and which is the good feature of Kafka, which I think you should use if your application has high load of data. So these things were missing from our application. And also with the batching comes the compression choices. To enhance the capability of batching, also there is a process of compression given by Kafka, which also you can use. We will understand and discuss these compression types in the next slide. But for now, I just want to talk about batch size and linger.ms, which we tweaked a lot to improve our resource consumption and to also to reach on the high throughput. So in Kafka, we have different compression choices, which ensures that which also actually depends on very much on your application use case. Like some compression type has high CPU usage, some has high compression ratio, some has very high compression speed. So it altogether depends on your use case, that which compression choice suits you in the combination with the batching. So compression mostly is powerful and is useful when you use batching. Otherwise, using compression type none also would suffice for your use case. You don't need high throughput, or for you, without compression, it's fine. So basically, compression choice none is mostly for latency sensitive applications, I would say, mostly, which is the major use case. So yeah, then you don't need to change with your compression type, and you can keep using none. But then you can use snappy if you want to provide a good balance between your compression efficiency and the speed. So snappy will increase your CPU usage a bit, but it also gives that output, that compression output, and it also improves your batching process, and it basically reduces the size of your message. But if you go for zzip, it has a very high compression ratio, but it's also very high CPU intensive at the same time. It takes lot of CPU resources. So if your compression efficiency is more important than speed, like in archival process, then you can use zzip, and you can use snappy if you want to use balanced performance, like a general use case. You can play around with snappy or none. If you have a high throughput application, you can try LZ4. So in LZ4, your speed is high, compression speed is high, and your compression efficiency is also good. ZSTT is it's like a modern compression algorithm. It provides high compression rate, but with moderate CPU usage. But yeah, I did not find it good enough for our use case and performance wise. But yeah, I really like Snappy and LZ4. Like when I experimented it, I really found them as useful when I tweaked them. So if you want to optimize performance or anything in your Kafka producer, you need to select the Kafka compression type based on your own use case. For general, Snappy and LZ4 are good. For archival, zzip could be good because of its high compression efficiency. And I'm not sure about ZSTD, but it's also good for very good compression speed. But yeah, CPU usage also increases with it. The redemption arc. So once we have identified and understand the configuration issues and the errors, we embarked on a journey to optimize our Kafka producer and optimize our own Kafka setup and experiment with the configurations to achieve high optimum performance. First, let's tune our batch and linger as we discussed. So what we do, because I mentioned that we need to tweak the batch size and linger.ms values according to our own use case. But how do you know the exact value? How do you know the optimum value? For that, you need to experiment. You need to actually play around with these values and monitor your throughput, monitor your latency, monitor your batch size. So by incrementing our linger.ms and batch size, we were able to find the sweet spot that works for our system. So if you see in that graph, we played with linger.ms 10, 20. We also played with other values like 5. I have not added that in my presentation. And we played with the batch size, starting with the default values 16 KB. So we increased the batch size, we increased the linger.ms, and we measured the throughput. So if you see, we see when we were increasing linger and batch size at the same time, initially our throughput increased. But then after some point of time, like when our batch size reached 64 KB, our throughput started decreasing. So probably for our data load, that much batch size was not required. For us, 64 KB batch size was enough. And linger.ms, for 10 and 20, we did not see much difference in the performance. But yeah, with linger 20 ms, the performance was higher. So we chose linger.ms as 20 ms and batch size as 64 KB for our application. So if you see, our throughput was like around 250 messages per second with these values, but that is considering that we are sending message to the Kafka as well as we are also updating the status in our database. We are also maintaining the status in our database. So we have two network transactions, communications involved. Because for us, high load is important, but data consistency also is also very crucial for data completeness. So that was the result of our experiment. Increase in throughput with different batch size and different linger.ms configuration. But it's very important to find the exact value which works for your system, and for that you need to experiment with the different values and measure the throughput of your application. Without that, you won't find the optimum value. It's nothing like one size fits all solution. Your solution might not work with these values. They might need different configurations. So it really depends on the data load of your application and what are other parameters configured in your producer, in your Kafka broker. So choosing compression. So now we know what works for us in batching. But then, as I mentioned, that compression complements batching. It reduces network usage. It compresses your message. So we carefully selected the compression type to optimize our performance. And for us, Snappy was okay. So we used Snappy. We continued with Snappy, and ZZip, we saw that our CPU usage was very high. There also performance was good, but because of high CPU usage, we did not use it. And yeah, I believe Snappy was good, and we started using it for our use case, and it was configured as none before by default. Monitoring performance. This is very important. Your data behavior actually changes over time. It's not important. It's not compulsory that right now with your data load, your Kafka is behaving well, and then in future after 5 years or in 2 years, your Kafka will behave the same. Your data load keeps changing. You have other different requirements, different use cases. So that's why monitoring performance of Kafka becomes very important, to know the problem initially at the first place. So that's why my recommendation will be always monitor performance of Kafka. With Kafka, monitoring performance becomes more important. For that, you can use Prometheus and Grafana. You can use Confluent Control Center. So there are different tools to already do that. And as in best practices, I would suggest it's good to monitor consumer lag, your broker health, disk usage, and throughput at least at minimum level to know any issues on production in advance. Also, you can set up alerts for anomalies and any kind of failures in your application. And it's good to also use dashboards for real-time visibility. So it really helps. Lessons learned. So while optimizing our Kafka producer configuration, we learned some key lessons regarding batch size optimization and linger.ms optimization. Increasing your batch size allows your throughput to increase, and increasing with linger.ms, but also it reduces the latency. So if you see this diagram, here on x-axis you have latency, on y-axis you have throughput. So when your throughput is increasing, your latency is going down. So when your batch size and linger.ms is increasing, when you increase that, your throughput will increase, but your latency will go down. And if you reduce the value of batch size and linger.ms, your latency would be low. So when your throughput increase, you would have high latency. And when you have low latency, then you would have low throughput. So you need to see that what is important for you, low latency or high throughput. If you really have, by default, Kafka is configured for low latency. So if you want to have high throughput, you really need to play around with these parameters. And if you see that, okay, your throughput has increased, but your latency is also gone high. So to reduce it, you really need to reduce your batch size and linger.ms to bring your latency to the optimum level. So that relation is very important to be understood. So as I mentioned previously also, there is no one size fits all solution. You need to play around, experiment, and find the best balance that works for your application. Best practices. So those are some recommendations and best practices that we'll suggest. Monitor from day one. Don't wait for issues to arise. Set up your monitoring tools like Prometheus, Grafana early. This gives you the visibility of your system health and helps catch any issues in advance, in starting point only, any problem before they escalate. Test configs early. Your default is always not optimal. Kafka has many tunable parameters provided. So you need to really, you cannot assume that this will work for your use case always. So you need to start testing different configurations in a controlled environment uh, at early stage. Default values are not always optimal in all Kafka use cases. Balance reliability and performance. So it's a trade-off, right? For example, if you enable idempotency in your application, it will increase the reliability, but it will at the same time also impact your throughput. So it really depends that what is important for you and how do you want to balance your application. So you need to really understand your system's priorities and adjust your parameters accordingly. So understanding systems requirement and priority is first important. Performance test with the production like data and production like environment. Before going live, you should always try to simulate real world traffic in production like environment before. This would help uncover any bottlenecks and ensures your system can handle the unexpected load. Even I would suggest that always have a test with the more load than the production before going live, because as I mentioned, as the data load changes, your Kafka performance changes. So it's very important that before going live, you should have a performance test with Kafka if you suspect that your load is going to increase on production environment in coming time. So you should be prepared in advance. Now, here comes my closing thoughts. So we are almost coming to the end of the session, and I want to leave you with some reflections of mine. So these are just some common reflections. Designed for the failure, not just for the happy path. So in real world system, things will break. What matters is how much prepared we are for it, and how did we tackle it, and how quickly we recover from it. So that's more important. So that's why I say design for the failure, not just for the happy flow in your application. Misconfigurations are part of the journey. They are not mistakes, they are stepping stones. Every issue we faced taught us something new about Kafka, Kafka producer, and this journey continues. And each challenge makes us, of course, the better engineers. So that's why it's important to enjoy this journey and to learn from your mistakes. Kafka defaults are Kafka requires more than the default settings. If your system has demanding needs, then Kafka defaults won't work for you. You will need to go deeper and understand the internals of producer and Kafka. And that's where the real learning begins. Don't blindly follow benchmarks. What works for someone else might not work for you. Your use case is unique. So experiment, measure, and iterate. And that's how you grow. So as I mentioned, you really need to experiment with the different parameters on different stage. Like you have batching stage, you have stage where your message is sent to the broker, you have a stage where Kafka retries. So you need to really see which stage is blocking your performance, latency, throughput, reliability, durability, anything. What is affecting the performance of your application? Accordingly, you need to experiment with those default configurations and see what is helping you to improve the performance as per your user requirement or your system requirement. And finally, a personal note. This is not about getting everything right in the first time. It's about evolving, adapting, and learning from it. And I hope it inspires you to embrace your own learning curve, because every misstep is just a step forward in disguise. So with that, I will say thank you very much for listening me. I'm Nupur Agarwal. I'm done, and I'm happy to take questions from here, from the audience.
Hello. Yeah, so thank you for your talk. I wanted to understand the use case a little bit more. Like,
Yeah.
what was the content of the messages, or yeah, what was it that you were trying to move through?
It was mostly kind of, we we have a system as like source of truth. So we have a data which we if anything is changed, we wanted it to send to our downstream systems, and downstream system should have a replicated data of our database. So they should have the exact same data that our system should have, and the data flow speed and data flow data load was very high every day, because data was coming via files, batch, through APIs. So from many sources, that data was coming in our producer database, and we wanted to send data to our downstream systems, but we also wanted to ensure the data consistency is maintained and we are not losing any data.
Okay, thank you.
Hi, Nupur. Thanks for a really interesting talk.
Thank you so much.
It's good to see the experimentation particularly on the producers and the batch
Yeah.
sizes. One of the questions I had is, when you were doing this, did you look at the operating system at all and possible tunings around what you can do in the operating system to complement what you're doing with the batch sizes?
I mean, yeah, we also saw the CPU usage, like, and in the CPU usage, we can see that when we tweak the batch sizes, with some batch sizes, our CPU usage also increased. But but I think for us, what was more important was having the high throughput.
Yeah.
So for that, it was okay. And for the operating system, we were using mostly the Linux and Kubernetes and OpenShift.
Because one of the things you can do in, say, Linux is there's a thing called the TCP buffer size,
Yeah.
which defaults to 16K,
Yeah.
which is why the batch size defaults to 16K as well.
Yeah. Yeah.
So if you don't increase the TCP
Buffer size.
size, what happens is the OS will break that 64K
Yeah.
into 4 transmits,
Yeah.
and the producer thread will block if it can't keep up with the OS, which increases the buffer memory,
Yeah.
in your producer. So sometimes you'll get better throughput if you increase the TCP buffer size to match your batch size.
Yeah.
And you get better kind of transmission across the network.
Yeah. But I think buffer memory also has other data, right? Not only the batch data, but also have the other data.
It's in the context of the producer, when it starts to block because the producer thread is putting more data into what the network can transmit.
Yeah.
The buffer memory is used to back up the memory.
Yeah.
And then when it catches up, it uses that. And
Yeah.
if the buffer memory overloads, the producer throws an exception.
Yeah.
So in our testing observations, if you do tune the TCP settings
Buffer
at the kernel level, the
Yeah.
batch size retransmits, it massively improves the throughput as well.
But buffer memory can also be tweaked at producer level, right?
It's more a question of you don't want to use the buffer memory
Yeah.
because it has a knock-on effect of the JVM with storing things. So if you tune at the TCP kernel level, that it sends the packets out at say 64K instead of 16K, it means the OS isn't breaking it up into 4 transmits, which then blocks the producer thread, which then pushes into buffer memory. So the idea is to get it out as quickly as possible by increasing that buffer at the TCP level. It's be worth experimenting with.
Thank you for sharing.
Sorry, it's
no, thank you. Thank you so much for sharing. I will definitely try that also. Thank you.
Yes, hello. Thanks for the talk. To extend a bit on what has just been said, another interesting tuning at a network level is to enable jumbo packets, jumbo frames, to have larger TCP packets, because by default they're quite small. So according to the workload, we experimented a bit with it, and there we saw an interesting increase in the kind of capacity, less overhead in just managing on the network layer. But okay, there a lot of things can impact the throughput. But we did so it might, if necessary, be also interesting to see if enabling larger TCP packets may help in attaining a larger throughput. But it's just one of the many fine tunings you can do on the network level, beyond Kafka itself.
Yeah. Thank you so much for sharing your insights.
Oh, thank you for your presentation. I just want to have one opening question about the schema registry.
Yeah.
Based on your experience, do you think for small projects with small amount of data, this is something mandatory, or you can avoid it? Because we experienced that, and for the schema registry, it's not something that you can configure easily, or something it costs some price. So with the alternative of open source, you think this is something that we need to have, or we can go on production if you have small projects without the schema registry?
Yeah, good question. So I think for small projects, it's my personal recommendation. I don't think schema registry is needed. But it's good to have, as you know, like in API you have Swagger and you are sticking to some data schema. So like that, and if you have schema validation and you are changing anything at producer end, you would know in advance that you are breaking something. So it's good to have that contract between the producer and the consumer, and especially if producer and consumer are two other systems in different domains or in different different entities of the company, it's really good to have schema registry. But like if your producer and consumer are your own applications, or they are kind of related and it's a very small project, then I think you can, I will say yes, it's a bit overhead. So you can also skip using schema registry. But like if in audience, if anybody has any other opinion, please feel free to share. That's my opinion. Yeah, I guess. Yes.
Okay. And just another question about the high availability.
Yeah.
For example, for on-premises installation of Kafka between 2 clusters, there is something that's called Mirror Maker 2. So do you have some, share experience for us about that?
So generally, like in our company, we don't maintain the Kafka cluster. So it's a platform team who maintains cluster, and it's provided to us as a service, and we just use that as a service. And yeah, but it's very important that when you tune your producer configuration, it also some properties depends on the broker configurations when you tune the parameters on the performance of your application. So we mostly have our producers and configures configured, but we cannot tweak anything at the broker side, like at the cluster side.
Okay, thank you.
So yeah, thanks.
One last question. Thank you.
Thank you so much for listening, and thank you. And I'm here for 2 days, so feel free to pitch me in for any discussion and questions. Thank you so much for listening.